instant response, and we're down to the second chapter about investigating Windows systems, which is the registry. So let's take a look at that. And let me get this so it fits in the projectable part of the screen. Looks pretty good. All right, so today's just the registry, and next time we'll have some more parts of Windows. So the Windows registry. In the old days of MS-DOS, you would have these text-based configuration files, just plain text files for each program, the way Linux does. If you have Apache, it comes with apache.conf and you adjust it there. But Microsoft decided to sweep all those little configuration files for all the programs into a binary database which contains all the configuration for Windows and all installed programs. And so tons of useful things are here. It also has all kinds of records of what you've been doing. It's not intentionally spying on you, but just for performance and convenience, it keeps track of what you've been doing so it can more easily repeat those actions later. So these things are called hive files. There are 5 main registry hives: system security, software, SAM, and default. And these are the root hives. And then each user, in your user profile, you have 2 registry hive files that apply when you log in. NTuser.dat is the most important one that has most of your personal settings, and userclass.dat I think just has associations of files to file name extensions, but whatever it is, there's nothing too important in user classes, I remember. So when you first log on, Windows will create a profile folder for you in C user's username, and if you connect over the network, you don't get a profile folder. So here's what you see in the regedit, which is the main tool to view the registry. Here's the keys, and these are values, and that's the data. These things look like folders, but they're not folders. They're called keys. They cannot be empty. They always have at least one item default its value is not set. And you can add more values here, and those are going to be settings for things like this is something to do with internet settings, whether a proxy is enabled. Just going to check for comments. Elon's usage is microdosing. Well, yeah, I don't know. People argue. Yep. Anyway, so all right, so here's the root keys at the root of everything. Everything else is a sub-key beneath these that you hit by hitting the plus sign. And so HKey users is one of the screwier ones. It contains a default hive, and it has HKU security identifier for each user. Each user account has a security identifier, which is a long number, mostly random numbers. At the end, it has like 1,000, 1001, 1002 for the normal user accounts, and lower numbers for the system accounts, which is the same system Linux uses. And so you have, this is where you have the ntuser.dat data goes into here, your particular HKey user's subkey, and also your user class hive file. And so every user's data is stored in the registry here in HKey users, but when you log in, one of you becomes the current user, and that will create the HKey current user hive, which is just going to point to a sub folder, a sub key of the HKey users hive. All right, now a bunch of these are only visible in RAM, and they are not stored on the disk. HKey current user is not stored on the disk anywhere. It just links to HKey users, and you won't catch this in a registry capture, not directly. Same thing with current control set. The control set is the hardware that your machine is connected to, and Microsoft planned long ago for things like laptops that will have a docking station where they connect to like one keyboard and monitor, and on the go where they aren't connected to that keyboard and monitor. So during boot up, your system probes to see which hardware profile is appropriate and then boots into that, and it saves these as control sets. And so the current control set, it only knows when it reboots. It knows which of these is the current control set, and the same thing, it only knows what the current user is when the user logs in. All right. So there are timestamps. There's only one timestamp in the registry. It's on a key, not in a value, and it's changed when any value under the key is changed, but not when subkeys values are modified, so it's not extremely useful. All right, let me check for comments. Yeah, all right. So here's run keys that launch on Windows systems. So this is one of the good places for malware to put it. And you cannot tell when these 3 run keys were added because it's current version run. You've got VMware Tools, Adobe, and WinUpdate. And so there's 3 showing key last time. They're all exactly the same. And so it's stored on the key, not on the value. So all this tells you is that something was changed about the run key at that time, but you don't know which of these was added. So it's not, again, it looks like folders in a file, but files in a folder, but it's not. If these were files, they would each have their own timestamp. It's not really true in the registry. Windows, the last update time is also pretty unreliable. Sometimes it's wrong. Whole bunches of it are updated during updates or a reboot, and attackers cannot easily change it. So the timestamps mean a whole lot less in the registry than they do in the file system. Now, there's another issue we talked about before, I think. If you want to install 32-bit software on a 64-bit Windows machine, that is supported, even to the extent that when the 32-bit software attempts to save things in the registry to keys that do not exist, it redirects them all. So into the Windows on Windows 64 subsystem to alternate registry keys with WOW in the name. So the 32-bit software saves something in the registry, and when it tries to find it, it finds it there, but it's not actually changing the 64-bit registry, which would potentially harm the system by overriding values that are not compatible with the 64-bit OS. All right. So here's various types of registry keys with important data in them: system configuration, shim cache, auto run, and user hive. So the system config, registry keys, the computer name is here in current control set computer name. Here's the Windows version. Here's the time zone, which is really important because the time stored in the machine is local time, and if you don't know the time zone, you don't know when things happened. And there's a list of installed applications here in the uninstall folder. And there's a list of mounted devices with drive letters. These are important basic things you will want to know. And my favorite, USB store, I mentioned before, shows every USB device that has ever been connected and gives you complete information about it. And you can therefore, you look here first whenever you're doing a police seized device, because then you want to write another court order to seize all these USB devices, because if you thought there was evidence on this computer, then there's very likely to be evidence on all these external devices that were connected to the computer. Then there's network information showing you about the wireless networks, file shares, firewall settings, and so on. There's user and security information. The audit policy, by default, Windows machines don't audit much or anything, but you can turn on auditing if you want to. I don't know how many people would do this, except at companies. Fast to the profile folder, group membership, these are things you'll find. And the shim cache. The shim cache is the application compatibility cache. This is because, like I say, you can run old programs on new versions of Windows. And when you do, it often has to make adjustments to make the old program run. And that's what's in the shim cache, to make the application compatible with a more modern operating system. So it may have information about when this file has run. And here it is in the app compat cache, way down in the current control set. It's maintained in memory and written to the registry on shutdown, which is the way all profile information works on Windows. And so it's got 1,024 entries, more than the prefetch, and therefore lists all the things that have been run recently or that have been adjusted for compatibility recently, even if they haven't been run. And so here's an example. The shim cache parser is a tool that will let you see it. And like a lot of old-fashioned Windows things, it stores things in a strange binary format, so you have to have a special tool to unpack it. And this will unpack it and then show you SQL has been running in this program, and S service host and B and act.exe, and it shows you when they were last modified. So you get some information about these programs. All right, let's try a Kahoot. Let me see if there's comments in the chat, and there are not. Here's the Kahoots. 12B1 is here. All right. I thought the stoners might be absent today, but maybe not. Anyway. All right. All right. Which one has several instances on a single computer? NTuser.dat. There's one for each user profile. Takes effect when you log in. There's only one system, but there are many users. At least there could be many users. All right, which one is not included in a captured hard disk image? Right, the current control set is not defined. It's not anywhere on the hard disk. It's in the registry, but you don't know which one of them is current. You have to look elsewhere to find out which one is current. The current control set is where most of the settings you adjust in the registry are, but they're not saved directly in a path like that on the hard drive. All right, which one gives you 128 recently used programs? That's prefetch. We talked about it before. Windows stores that information so it can load those programs into memory, imagining that you will probably want to use them pretty soon. And which one is only present on a 64-bit system? Yeah, the WOW 6432 node is the system where it will record what 32-bit programs want to save to run on a 64-bit system, Windows on Windows. All right. So, here's some auto-run registry keys that are commonly used to launch programs every time you restart, which is something malware often wants to do. These things are called auto-start extensibility points, and there are dozens of them. So they load the program when you boot in or when you log in or other conditions, and there are apparently hundreds of them, some still undocumented. Services is quite common. Services launch when you can adjust them to launch at various times, but typically they launch during startup, and they run in the background. And you typically run in a system or other services like network system or local service. If you want them to launch before you log in, they'll have to have one of these system accounts since they don't have a user account to use yet. And they're all information about them is stored in the registry. Current control set services service name tells it how the service is going to start, the path to the executable, the type of service, and so on. You'll see them here. Most services are run as DILs, not EXEs. And so there's a DIL here. They launch as rundil.exe and then load it. Or SVC host, pardon me, service host. So services.exe is the command line service control manager. you can use the SC command. This is the graphical one, pardon me. The graphical one I just showed you that lets you see what services are doing. Yes, that's registry editor. We'll get to it. Here's services. This graphical one where you can see all the services and you can start, stop, or disable them, or right-click them and go in properties and change other things about them. If you can also control them all from the command line with SC to examine, start, stop, or create a service. So SC looks like this. I can look at this service WUAU serve, and it'll tell me what it is. It's a share process, it's running, and some more information about it. 1EXE can run several services, so if I do task list /SVC to show the running services, it will show me service host. This is running 2 services. Here's a service host that's running what looks like about 10 services, which it's loaded as libraries. It's running them there. All right, and here's 4 of the common run keys: Microsoft Windows current version run or run once. And there's also one under Software Microsoft, run once, run once. These are all things that will cause things to automatically launch on a reboot, at least one time. And so here's active setup. You can point, it goes to a GUID, which are these long, random-looking numbers, 128-bit numbers in hexadecimal. And this is intended to help with installation and updates. All right. And app init DILs are DILs that will be automatically loaded whenever any user mode app linked to user32.dil is launched. And the idea is user32 is the user interface. Things like buttons and key presses and such go in through there. And if you have, say, a special keyboard, like a special keyboard for usability by someone who's handicapped or something, then you would want everything with the user interface to load the DIL to connect to that special keyboard. That's the idea here. So that's what the app init DILs are. And if you were to add something to the app init DILs like malware, then as soon as something opened that had an interface to the user, it would launch the malware. I'm going to check for comments. I can get to it. There we are. Okay, nothing new. All right. So there we are. Now it's supposedly disabled, but Secure Boot is enabled. So that might be good. I'm not sure if they're still using it. LSA is another big flaw, at least up through Windows XP. This was Local Security Authority, intended for authentication packages. The main thing I know about it is that you can query it to find a plain text copy of the administrator password, at least up through XP. I think they fixed that. But there's packages here. Authentication packages are used here, again, to allow you to have strange modes of authentication. Like for Windows XP, you could plug in a USB fingerprint reader and things like that. Then there are browser helper objects, which were plugins for Internet Explorer, no longer supported in Edge, so I think these are pretty much out of date. Only people running old versions of Windows should still have Internet Explorer. And then there's shell extensions for Windows Explorer. So when you right-click a file, other things will appear. Like, when you install 7-zip, when you right-click, there'll now be some 7-zip options there. So those are stored here as shell extensions. And you'll see them here. Here's my shell extensions on one of my machines. It has 7-zip. This was added when I installed something. And WinRAR, that sort of thing. WinLogon shell is the shell that loads when you log on, which normally is Explorer.exe. So when you log on, it shows that. Just like Linux, you can, in principle, load different shells, although almost nobody ever does load anything else on Windows. And you have user init. This will load your logon group policy scripts, and you can append additional executables to this value, so it will then run extra scripts when you log on. So you want to find malicious autoruns. You can look at things that are automatically launched and just sort of look at them to see if there's something suspicious about them, like spelling errors or something. But this is a pretty sloppy way to find it because some legitimate stuff is misspelled and some malicious stuff is spelled correctly. So, for example, here, it's pretty hard to tell. You got hpdj.exe running, rinp32.dil for route updates, RF alert, and synerg-c to see which of these is malicious. And I don't remember, but I do notice that iprip is spelled wrong. IPNP down here, that seems a little screwy. But yep, that's the one. Okay, but it's not. This is not a good way to detect malware at all, any more than it's a good way to detect phishing. You just can't count on the good guys to spell things right or the bad guys to spell things wrong. So here's the recommended steps. Check to see things that are signed by trusted publishers like Microsoft and figure those must be okay. Consider things that were created, but they're created outside the timeline of the incident you're inspecting, so they're not part of your incident. Then look at the paths of the remaining binaries. Attackers often use temp folders or things within system root, common directories, deeply nested. So you might see them loading things in a strange place. That would be a clue. Then look at the MD5 hashes for remaining things on VirusTotal or one of the other online databases of malware to see if it's known malware. And the remaining unknown things, you can compare them against your known image, if you're at a company that we used to install the system, and see if they were included in your original image or not. And then you'd get down to a relatively small number of files to examine further because they seem to be malicious and might be malware. The best tool, of course, is autoruns. Autoruns will show all the automatically launching programs, or at least most of them. There's nothing that finds them all, but this finds more than any other tool. And, of course, signed malware. There have been quite a few news stories about real malware that is signed with valid signatures because they've somehow been able to steal good code signing keys, and so that's an issue. Also, even things that are unsigned might not be malicious, unfortunately. All right, let's take a look at the, how do I get approval for 197, 198? Well, I'm not sure what it means. Let me do this Kahoot and then I'll answer that one because I'm going to see if I can find the coots. Here they are. 12B2 is here. All right, command line utility. SC, Service Control Manager. Good. All right, which one will launch whenever a program that draws windows starts? The app init DILs, although maybe not in modern versions of Windows. And what about the Yahoo toolbar? I don't know if you remember this thing. Those are browser helper objects attached to Windows Internet Explorer. Again, not something you'll see on a modern system. And which one is set to Explorer.exe? logon shell. All right.